Hello friends, in this video we are going to discuss about common drain configuration or common drain amplifier. This is also known as source follower. So first we will see this configuration. So this is VDD, this is VI, this is Vout. This is some bias current IB. First we will prove why this is known to be a source follower. Okay, and one more thing here, drain node is common to both input and output. That's why it is known as common drain configuration. Now we will prove why this is known as source follower configuration. Okay, so let's draw its small signal model. So this is Vi, this is V0, this is ground. Now we have removed IB, I bias current, because it has infinite resistance idle current source. That's why. So now here ID current will flow. Now output node is floating. Therefore ID equals to 0, current is 0. So GM VGS, ID is GM VGS equals to 0. Now this circuit is biased at some constant I bias current. Therefore GM cannot equals to 0. So because of this VGS equals to 0. So VG minus VS equals to 0. VG equals to VS. So VI equals to VO, or VO equals to VI. So V output equals to input voltage. That's why this is known as source follower. Okay, now we need to find out DC gain. So for DC gain, for this we need transconductance and output impedance. Okay, so here we are considering lambda equals to 0, RO equals to infinity. This is our assumption. Now so we are assuming lambda equals to 0 and or RO equals to infinity. This is our assumption. Okay, so first we will find out GM for circuit. So this is VI, output node, we ground this, and ISC current flows from this. Now in this case ID, this is ID equals to ISC equals to GM VGS. So ISC equals to GM into VI. ISC upon VI equals to GM. So GM equals to this, equals to GM. Now suppose lambda not equals to 0 or RO is finite. So let's consider this case. So here RO, and this is Vi, and this we make ground. Now we can neglect this because both terminals of RO is ground, so it will reduce to this circuit like this. ISC, this is VI. So for this case also GM equals to transconductance equal to GM. Now let's find out R out. R out when lambda equals to 0 and Ro equals to infinity, and lambda not equals to 0 or Ro equals to finite for this case. So for this case we make input ground, we put some Vx voltage source, we make it ground like this. So now say this is ID, this is Ix, ID equals to ID plus Isc equals to 0. ID is Gm VGS 0 minus Vx equals to hyphen Isc. Gm Vx minus equals to minus Isc. Oh, sorry, I have written something wrong. We are assuming not short circuit, but we are taking it as a Ix current. Ix. So negative sign cancel. Vx upon Ix equals to 1 by Gm. This is R out. So for this case R out is 1 by Gm. So DC gain ADC equals to Gm into R out. So Gm R out is 1 by Gm. So ADC is 1. So what does this mean? This means Vi equals to Vo. Vi fully track Vo if Ro equals to infinity. Now let's consider other case when lambda not equals to 0, Ro is finite. Let's find out output impedance. So Ro will come here, this is ground, here we are putting Vx, here ground. So this is ID, this is Ix, this is say IR. So ID plus IR plus Ix equals to 0. ID is minus Gm Vx plus 0 minus Vx by Ro Ix equals to 0. So we are applying KCL at this node. So Ix equals to Gm plus 1 by Ro Vx. Now Vx upon Ix equals to Ro 1 plus Gm Ro. So DC gain ADC equals to, this is R out, Gm into Ro 1 plus Gm Ro. So Gm Ro 1 plus Gm Ro A naught 1 plus A naught. A naught is Gm Ro, where A naught equals to Gm Ro. Now here ADC is less than 1, so Vi less than V out. So there is attenuation, and you can say Vi follow V out, but there is attenuation in amplitude. So this circuit is known as, common drain is known as source follower. If Ro is very high, then Vi fully follow input. Thank you.